All right, welcome once again to Fully Theoretical. We're going to continue with Algebra 2. This time we're looking at polynomial division in Khan Academy. So we're right at the start here for the polynomial section within Algebra 2 for Khan Academy. So we'll start right here with the introduction.
Familiar with the idea of a polynomial, and we've spent some time adding polynomials, subtracting polynomials, and multiplying polynomials, and factoring polynomials. And what we're going to think about in this video, and really start to think about in this video, is the idea of polynomial division. So for example, if I had the polynomial, and this would be a quadratic polynomial, let's say x squared plus 3x plus 2, and I wanted to divide it by x plus 1. Pause this video and think about what would that...
Whoa, hit the wrong button. Let me see if I can get back to where I was.
That be? What would...
There we go. So we have x squared plus 3x plus 2. X squared plus 3x plus 2 over x plus 1. So I know there's a couple ways of doing this, but probably the easiest way in this case is just to say x plus 1, so times another polynomial. We'll know that because there's an x squared, so obviously there's going to be an x here because we have to multiply x by x to get x squared, right? So, and then there's 3x. In order for there to be 3x, we would need 1x plus a certain amount of x, and that has to multiply out to equal 2. Well, so this one's obviously really easy. It's just 2. We know it's plus 2 because that's a plus and that's a plus. So, I mean, obviously, first video in the series, you know, first question, it's a pretty softball question. So let's see what else we got. Oh, I'm sorry, I have to click here.
What would I have to multiply x plus 1 by to get x squared plus 3x plus 2? Well, one way to approach it is we could try to factor x squared plus 3x plus 2, and we've done that multiple times in our lives. We think about, well, what two numbers add up to 3? You know, if I were to multiply them, I get 2. And the one that might jump, or the ones that might jump out at you are 2 and 1. And so we could express x squared plus 3x plus 2 as x plus 2 times x plus 1. And then all of that is going to be over x plus 1. And so if you were to take x plus 2 times x plus 1 and then divide that by x plus 1, what is that going to be? Well, you're just going to be left with an x plus 2. This is going, I don't have to put parentheses. This is going to be an x plus 2. And if we want to be really mathematical...
Okay, so I always fail at things for missing the actual question. This isn't the answer to the actual question, because this is the question. This was what we divided by, so this right here is the answer. Not this, just that. So, if that wasn't already obvious.
Precise, we would say, hey, this would be true as long as x does not equal -1, because if x equals -1 in this expression or in this expression, we're going to be dividing by 0, and we know that leads to all sorts of mathematical problems.
And obviously I missed that too, but we'll just move on.
But as we see, for any other x, as long as we're not dividing by 0 here, this expression is going to be the same thing as x plus 2. And that's because x plus 2 times x plus 1 is equal to what we have in this numerator here. Now, as we go deeper into polynomial division, we're going to approach things that aren't as easy to do just purely through factoring. And that's where we're going to have a technique called polynomial long division. Polynomial long division, sometimes known as algebraic long division. And if it sounds familiar because you first learned about long division in 4th or 5th grade, it's because it's a very similar
By the way, if you hear me slurping, I'm sorry. I just made coffee and it's amazing.
process where you would take your x plus 1 and you would try to divide it into your x squared plus 3x plus 2. And you do something and I'm going to do a very quick example right over here, but we're going to do much more detailed examples in future videos. But you look at the highest degree terms. You say, okay, I have a first degree term and a second degree term here. How many times does x go into x squared? Well, it goes x times. So you put the x in the first degree column, and then you multiply your x times x plus 1. X times x is x squared. X times 1 is x. And then you subtract this from that. So you might already start to see some parallels with the long division that you first learned in school many years ago. So when you do that, these cancel out. 3x minus x, we are left with a 2x. And then you bring down that 2. So 2x plus 2. And you say, how many times does x go into 2x? Well, it goes 2 times. So you have a plus 2 here. 2 times x plus 1. 2 times x is 2x. 2 times 1 is 2. You can subtract these. And then you are going to be left with nothing. 2 minus 2 is 0. 2x minus 2x is 0. So in this situation, it divided cleanly into it, and we got x plus 2, which is exactly what we had over there. Now, an interesting scenario that we're also going to approach in the next few videos is what if things don't divide cleanly? For example, if I were to add 1 to x squared plus 3x plus 2, I would get x squared plus 3x plus 3. And if I were to try to divide that by x plus 1, well, it's not going to divide cleanly anymore. You could do it either approach. One way to think about it, if we know we can factor x squared plus 3x plus 2, is say, hey, this is the same thing as x squared plus 3x plus 2 plus 1. And then all of that's going to be over x plus 1. And then you could say, hey, this is the same thing as x squared plus 3x plus 2 over x plus 1 over x plus 1 plus 1 over x plus 1 plus 1 over x plus 1. And we already figured out that this expression on the left, as long as x does not equal negative 1, this is going to be equal to x plus 2. So this is going to be equal to x plus 2. But then we have that 1 that we weren't able to divide x plus 1 into. So we're just left with a 1 over x plus 1. And we'll study that in a lot more detail in other videos. What does this remainder mean? And how do we calculate it if we can't factor part of what we have in the numerator? And as we do our polynomial long division, we'll see that the remainder will show up at the end when we are done dividing. We'll see those examples in future videos.
All right, well, that's it for this one. I guess tune back in for the next one, although you're not really tuning, but you get the point. All right, cool.